The following graph shows the graph of the position, velocity, and the acceleration. We don't know which one is which, but determine which graph is the graph of each, and then describe the motion of the particle using the graph. First, we notice that there is a straight line, there is what looks like a parabola, and there is what looks like a cubic. But the graph B is increasing and then decreasing and then increasing, which means if there is the derivative of the graph of B, the derivative would be above the x-axis and then below the x-axis and then above the x-axis. More than that, at the point where the red graph has a peak, there should be the derivative of 0. At the point where the graph has a valley, there should be the derivative of 0. And so we know from looking at the graph of A, the derivative of B, which we will write B prime for now, is A. Now, if we look at the graph of A, it has a valley, and at this valley, if it has the derivative, then the derivative should be 0. And so because of this, C is the derivative of A. And so the graph of B must be the graph of the position. The graph of A must be the graph of the velocity. And the graph of C must be the graph of the acceleration. Every time the graph of the position is decreasing, then the position should be below the x-axis. Every time the graph of the position is increasing, then the velocity is above the x-axis. From the graph of the position, we see that the position of the particle is increasing, and then the position is decreasing, and then increasing again. From the graph of the velocity, we see that the particle is moving forward, and then the particles move backward, and then forward. And then from the graph of the acceleration, we see that the particle accelerates from 2 point something on to infinity because the acceleration is positive. To determine where the particles is speeding up or slowing down, the particle is speeding up when the velocity and the acceleration have the same sign, whether positive or negative. The particle is slowing down when the velocity and the acceleration have the opposite sign. So we will focus on the graph of the acceleration and the velocity only, the blue and the green graph. From 0 up to this point, we see that the velocity and the acceleration have opposite sign. So this looks like 1.3, for example, or 1.4. And so we say that the particle is slowing down on the interval 0 to 1.3. From 1.3, or whatever this x value is, up to 2. Let's say that is 2.7. The sign of the velocity and the acceleration are both negative, and so we say that the particle is speeding up from 1.3 to 2.7 because they have the same negative signs, both the velocity and the acceleration. From 2.7 to 4, it looks like the acceleration is positive, but the velocity is negative. And so we would say that the particle is slowing down on the interval 2.7 to 4. And then after 4, the acceleration and the velocity have the same sign, so the particle is speeding up from 4 to infinity.